Now in this question we've got a continuous random variable x which has a probability density function given by this thing here. That's from 0 to 4 inclusive and alternatively 0 everywhere else. Okay, we've got to find out two things. The probability that x is less than 3, and secondly, if the probability that x is greater than or equal to some constant k, and that probability is a quarter, we've got to find the value of k. Alright, now this question is exam 1 style, probably about the right level, maybe a smidge harder than the right level, but not quite very hard. So I've still left it on amber, but it does take a bit of thinking, and it's a straightforward question if you find the easiest way of doing it. And I'm going to do this completely geometrically. I'm not going to be worrying about integrals under curves, guys, because this is easy to do geometrically. So let's draw a picture of what this probability density function looks like so that we can get a handle on how to approach part A and then part B. There it is. Now, is this correct? Well, it's an upside down one of those modulus functions centered around 2, and that's right, and it's moved up by 2 units. And now this factor of a quarter, let's just analyse whether that's right in terms of what we've done here with it. If x was 2, that would be a 0 term, and 2 over 4 would be a half, which would be exactly right. Okay, that looks pretty good to me. So now what we've got to do, guys, is work out the probability that x is less than 3. Okay, now there's the point there where x is 3. So we've got to work out that area, which is the halfway mark area, and that would be an area of 0.5 because this function is symmetrical about its vertex up here. And there's the blue hashed area between 2 and 3. So really we've just got to take 0.5 and add this area here. Or alternatively, I've also shown you a way of working it out by exception. If you work out this little vacant area up here, this little triangular area between 3 and 4, and subtract that from 1, that will be an equivalent result, and probably easier to do than be messing around with this blue hashed area here, which is a trapezium. However, trapezia are nice friendly little beasties and easy to deal with, so let's do it both ways and show you. That would be half, as I said, that green hashed area, and we need the coordinate. We need the coordinate of this point here, where x is 3. Okay, now if you plug that into there, you'll get 3 minus 2 is 1. That'd be minus 1 plus 2 would be plus 1. Plus 1 divided by 4 is a quarter. So that checks out. Okay, that's the coordinate point where x is 3. Now, okay, so the probability that x is between 2 and 3 is the area of a trapezium. So, and now how do you work out the area of a trapezium? Do you remember? It's the average parallel side length times the perpendicular distance between those parallel sides. Alright, now let's do that. So this one here has got a height of a half, this one here has got a height of a quarter, as we just found out. Add them up, divide by 2, multiplied by the perpendicular distance between x is 2 and x is 3, which is 1 unit, and you got your area of the trapezium, which works out to be 3/8. Okay? A half plus a quarter is 3/4, divided by 2 is 3/8. That's the answer there. Hence, the probability that x is less than 3 is going to be the green hashed area, which is a half, plus the blue hashed trapezium area, which is 3/8, and a half plus 3/8 gets us 7/8, guys, and that is our answer. Yes? Great. Now, alternatively, if we wanted to work out, as I was saying before, by exception, we could work out the area of the little vacant triangular area over here and then subtract that from 1. That'd be pretty easy too, because that's the area of that triangle is the base times the height, which is 1 times a quarter over 2, which gets us 1/8. We subtract that from 1 and we get 7/8, which is a great result as well. Same thing. So you pick which way you'd like to do it, but I wouldn't advise you go fiddling around with integrals and things under graphs, because it just takes longer and it's just more tedious and you're more likely to make an error. That's my thinking on that anyway. Alright, let's do part B. Now, we're trying to find the value of k if the probability that x is greater than or equal to k comes out at a quarter. Okay, find the value of k. Well, let's draw the picture again. Now, this is the way I see it. The probability that x is greater than or equal to k is a quarter, which is this orange horizontally hashed region here. Okay, and we've just got to find that value of k there, which corresponds to the orange hashed area being 1/4. Okay, so how would you do that? What would you do? Well, I think I would work out the area of this triangle. That's what I would do. It's pretty straightforward if you just approach it like that and you just plug and chug. Let's see how I did it. The area of the triangle on the right hand side equals 1/4, so we've just got to get that area in terms of k and then solve it, that area as being 1/4, and find the value of k that corresponds to that, guys. So now when x is greater than 2, we know that this is the important thing. When x is greater than 2, you can just drop this modulus sign here, because this term in here, x minus 2, would be positive. So therefore, you don't need the modulus signs anymore. This simply then becomes just minus bracket x minus 2 plus 2, all times 1/4, and it comes out to be this. All right. Now we've got our function for this right-hand sloping downwards curve here. All right. And now, having done that, if I substitute the value k in there for x, I'll get the y coordinate when x equals k. All right? And it comes to 1/4 of 4 minus k. So that's my height of the triangle. Now, all I've got to do now is base times height over 2, get that area expression in terms of k, which I'm doing now. You can see. There it goes. Half of, now this is the base. Now the base is 4 minus k. Okay, the base length is 4 minus k. That'll come out to be positive because 4 is a bigger number than k, times the height, which I've just worked out over here, as you can see. That is my area. Okay, that is the expression for my area. Just clean that up a little bit. That comes out to be 1/8 of 4 minus k all squared, and we know that that area is 1/4, don't we? Yes, now I've just got to chug through the algebra now and work out the value of k, which is appropriate. That's a quadratic-y thing, which will give me 2 answers. One of them I would assume I'll have to reject and say why I'm rejecting it in order to get my full marks. Alright, don't just reject things willy-nilly, say why. Alright, so we're saying that 4 minus k all squared is equal to 2 after I've multiplied both sides by 8. That's correct. Now I'm going to take the square root of both sides. Therefore, 4 minus k would be plus or minus the square root of 2. And then solving for k would be 4 plus or minus the square root of 2. You would have to know in exam 1 that root 2 is approximately 1.4. Actually, it's 1.414. I remember personally the square root of 2 and the square root of 3. I find that very handy. So the square root of 2 is 1.414, square root of 3 is 1.732. Remember that, guys. Put it in your brain, into your BIOS in your brain, and don't forget it, at least until the exam's over. Now, let's see. 4 plus root 2 has got to be about 5.4 then, and 4 minus root 2 is 4 minus 1.4, which will be about 2.6. So I'd say the 2.6 is the winner, because it has to be somewhere between 2 and 4. And the first answer we got was well above 4, which would be out of range. Okay, so yes, k has got to be between 2 and 4. Therefore, k is 4 minus root 2. How sweet it is, guys. And that's our answer. All right. I hope you got something out of it. If you didn't quite get it, go over it again and analyse it and absorb it so that you'll be able to do something like that in the exam. All right, we'll see you soon, and all the best.